Hello to all the emerging scientists joining us today. My name is Nico Kraus, and I am the co-sponsor of Henkel Researchers World in North America. As a company that produces adhesives, laundry and home care, and beauty care products, Henkel is passionate about science. Henkel Researchers World is a STEM education program designed to introduce you to the fascinating world of science and spark curiosity by putting you in the role of the actual researcher. Henkel is proud to bring this program to North America and offer children the opportunity to conduct science experiments about topics like green energy, recycling, climate change, and the lessons that you will learn about today. How much sugar is in your drink? Henkel Researchers World has already reached more than 62,000 children around the world, and today you have the chance to join in and be a researcher for a day. I'm going to hand you over to our science teacher to take you through the lesson today. So have fun today and stay curious.
Hey everyone, welcome to the 10th anniversary of Researchers World here in Stamford, Connecticut and throughout North America. My name is Trent, and today we are going to be going on a diving mission. Now, we're not going on a real diving mission, but we are going to be using a pretend diver to look at how much sugar are in our soft drinks. And so a soft drink is any sort of flavored beverage that is artificially sweetened. So that would be things like fruit punch, iced teas, lemonade, juices, and soda. Now, for the purposes of our experiment today, we will not be using soda because soda will affect our diver because of the bubbles in the beverage. It'll make him float automatically, so that will mess up our results. We are going to be using uncarbonated soft drinks. So again, that's things like lemonades, iced teas, sweetened iced teas, fruit punches, and juices. So hopefully you all at home have a couple of those ready to go that you'll be able to use while we do our experiment today. And so the mission, or the question at hand today for our experiment, is how much sugar is in our drinks? And why do we care about that, right? Why are we even going to spend some time looking into that? Well, sugar, while tasty and delicious, is not the best for our health. It can damage our teeth. It's bad for our blood. If we consume too much of it, it can even cause long-term damage to our internal organs like our liver and our kidneys. So we don't want to drink too much sugar. Although it is tasty and it does make our drinks delicious, we want to make sure that we're not overindulging and that we're enjoying it in moderation like everything else. So for today's experiment, there's quite a few things that you're going to need. You're going to need 5 identical glasses. So I have beakers here, which are an instrument that we use in a laboratory. I assume you all probably don't have 5 identical beakers at home, and that's fine. As long as you have 5 identical drinking glasses, preferably ones that are clear so you could see through them, that's really what matters. We are also going to need a whole bunch of household sugar, right? So just regular granulated white sugar. We are going to need some tap water, just regular water from the sink. You're going to need a tablespoon, like I have here, measuring spoon, size of a tablespoon. You're going to need a plastic straw. It's important that your straw is taller than your cups. All right? If your straw is not taller than your cups, we won't be able to record our results. You're going to need some modeling clay. That might be the trickiest part. You may not have modeling clay like this at home. However, if you don't, that's okay. We will talk a little bit later about something that you could do as an alternative to modeling clay. You're going to need a waterproof permanent marker. Mine is right here. And you're going to need a ruler. Additionally, for the end of our experiment, you're going to need a couple of those non-carbonated soft drinks that we were just talking about. So to begin our experiment, we need to have a control. whenever you're doing a scientific experiment, you need a control or a baseline, something that is unchanged, something that you're not adding any sort of variable to, that you can compare all of your other experimental variables to later on. For our purposes, and I've labeled the cup C to stand for control, it is just going to be regular old tap water. So I'm going to put 200 milliliters of tap water into this cup. If you don't have a measuring cup on hand to be able to measure off exactly 200 milliliters, that's fine. As long as you put an equal amount of liquid in each of your glasses, that's really what matters. Just for reference, this is how much 200 milliliters of water is. It's not that much. And again, it doesn't have to be exactly that. As long as you have about the same amount in each of your glasses, that's really what matters. So this is our control. Our control is just a glass of tap water. And I'm now going to fill all of my other glasses with 200 milliliters of tap water as well, but we will be adding some experimental variables to these. A good tip for all those young scientists out there is whenever you're pouring a liquid from one container to the other, you want to make sure that the container you're pouring into is flat on a surface, and then you want to get down at eye level to look and see when you get to just the amount that you want. Okay, so these jars that are labeled 1 through 4, these are going to be our experimental jars, and we're going to be adding some variables to these. So what we are experimenting on here, or really the variable that we are looking for in our experiment, is the change in density in our water. So to change the density, we're going to begin adding sugar to each of these jars. So I'm going to begin by adding 15 grams of sugar to jar number 1. Now 15 grams of sugar is approximately 1 tablespoon. A tablespoon is actually about 14.2 grams, but for our purposes, we're just going to round it up to 15. So 1 tablespoon of sugar goes into jar number 1. For jar number 2, we want 25 grams of sugar. So that's 1 full tablespoon, and then about 2/3 of a tablespoon. So that's going to look something like that, right? It's not quite a full tablespoon, but it's close. So that's got 25 grams. For jar number 3, we're going to add 35 grams. So that's going to get 2 full tablespoons plus an additional 1/3 of a tablespoon. So something like that, right? So 2 1/3 are going to go into jar number 3. And then for jar number 4, that is going to get 3 full tablespoons even for a nice whopping 45 grams of sugar. Whoa. All right. So now we've got our solutions. A solution is whenever you have mixed something into a liquid. So we've got our solutions, but you'll notice that there's clearly a bunch of sugar just sitting on the bottom of your jar. So what we're going to do now is take a utensil, spoon, whatever you have, and we're just going to start stirring these. And this is going to take a minute, and that's okay. It's sometimes when you're doing an experiment, sometimes these steps take a little while. So we're not in a rush. We're doing a nice, thorough job of making sure that we dissolve all of the sugar in our cups. And so I have a question coming in from the audience here asking, what is density exactly? And that's a great question. You can think of density as weight per volume. Now, what the heck does that mean? Well, imagine you have a pound of metal and you have a pound of feathers. Think to yourself, a pound of metal and a pound of feathers. Which of those weighs more? Initially, some people might think, well, a pound of metal weighs more. But actually, they weigh the same. They're both 1 pound. However, you need a lot more feathers to get 1 pound of feathers than the amount of metal that you need for 1 pound of metal, right? It's going to be a little tiny piece of metal. It's going to be a whole bunch of feathers. So although they both weigh the same amount, it's both 1 pound, the density of the metal is a lot higher than the density of the feathers. So I have my first 2 mixtures pretty dissolved. The number 1 should be pretty easy because that has the least amount of sugar in it. And number 2 is looking pretty good. You'll see some of the sugar settle back at the middle, in the bottom at the middle of the jar, and that's okay. But let's start by getting these as nice and dissolved as we can. So another way to think about density in the context of liquids like we have here is imagine floating in a pool or a pond, right? It's not impossible, but it's not the easiest thing in the world, right? Your butt probably starts to sink underwater. It pulls your head down below the water. And if you find the sweet spot, you can float, but it's not super easy. However, if you float in the ocean, it's pretty easy. And that's because of the salt that's dissolved in the ocean water, just like we're dissolving the sugar into our solutions here. That salt dissolved in the ocean water raises the density of that ocean water, and it makes it easier for you to float. So keep that in mind shortly when we get to our next step with the diver. And you should also notice as you're mixing these that your solutions with the higher amount or concentration of sugar is going to be darker and cloudier than your other solutions that have less sugar in them. I'm not sure if you could see it on camera or not, but my solutions here are significantly cloudier than my control and solutions 1 and 2. Okay, we're just about done mixing the solutions. I'm not seeing too much settling, which is good, but if you are getting some settling of the sugar in your mixture, just go back and mix a little bit more. That should take care of it. The sugar's dissolving pretty well. So we now have our control and our 4 experimental variables. What we want to do next is make our diver. Now, the diver is going to be made with modeling clay. I mentioned earlier that if you don't have modeling clay at home, that's all right. But what you are going to need is some white bread and some glue. Rip the crust off of your white bread. Make about a 1 by 1 inch square. Roll it up into a ball. Drop a little bit of glue in there. And just keep rolling it until you get something about the consistency of modeling clay. So I'll show you what my modeling clay looks like for those of you who are going to be using our bread trick. And for those of you using the modeling clay, you need much, much less of it than you probably think you do. This amount here that I have is probably about 4 times as much as we're actually going to need to make the diver. So we're going to take just a little bit of that, and we're going to start to roll it in our hand and try to make it as perfect of a sphere as we can. Nice and symmetrical, nice and round, and just even that is probably too big. So if that's the size of yours, break off some of it and keep rolling it. Okay, so you should have something that looks about like that. Once you got your clay ball or your white bread and glue ball, take your straw and gently stick the diver onto the end. You want to be nice and careful that too much of the clay doesn't get sucked up into the straw. If that does happen, you might have to start fresh. And that's okay. It took me a lot of practice. And just mold the diver right around the end of your straw. You want it to be as symmetrical or even all around as you possibly can. I understand that that is easier said than done, but the closer to symmetrical you could make it, the better. So once you're done with your diver, it should look like that. And now you could go ahead and drop them into your control. So I've had a lot of practice at this. I've made a lot of these divers. And unless you make it perfectly symmetrical, it won't stand up straight in the glass. It will tip over. And that's totally okay. We can still work with it. It's very, very hard to get it to stand up straight. But what we're going to do, once we have our control, is we're going to measure our baseline. Now remember, within this control jar, there's nothing other than tap water. There's no sugar, nothing else is mixed into this. It is just tap water. So that's like similar to my example of floating in the pool, right? Is it possible? Yes. Is it really easy? Not so much. So what you're going to do is get down nice and low, and you want to hold your straw. It should be not touching, the diver should not be touching the bottom of your jar, but it also is likely not truly floating. It's just kind of bouncing right off the bottom of your cup. And what you want to do is using your hand or using your ruler, try to get the diver to stand up straight against the edge of your jar. And from there, take your Sharpie or your permanent marker and just mark a little line on your straw. And make sure that you don't touch it with your fingers or smudge it or anything. Let that line dry before we do anything else. You can even blow on it a little bit to help it along. Okay, so now we see this is how much a diver floats or dives in water that has nothing in it to change the natural density of the water, right? There was no sugar or anything else dissolved in this water. So once we have our baseline, we could, if you want, you can mark it with a little C so that we know that that's where the control is. You don't have to do that, but if you want. And this is going to be the top line on our diver. And what we want to do is create a diver that looks something like this. You're going to take your ruler and mark off 15 evenly spaced lines. Use your ruler and try to make them 1 millimeter apart. Millimeters are very, very small, so it can be a little tricky. But remember, we are making 15 lines below our control line. Not above, but below it. The control line is going to be our top line on our diver. Take your time and make 15 little marks. And again, I'll show you what my finished one looks like so you can see that's what your lines should look like. 15 of them. Take your time. You don't want to smudge them. You don't want to make them too close together or too far apart. All right, perfect. I got 15. I'm just going to drop him back in my control for now. I'm going to give everyone a second to get caught up because I've done this a few times. Do we have any questions coming in from the audience? All right, it looks like we have a question coming in. My lab assistant, Elena. Thank you very much, Elena. Question number 4. Right, so somebody asked, what is a control? So a control is, again, the baseline for your experiment. The control is what we are going to compare all of our other results to after we've done the experiment, right? So our control in this experiment is just water. There's nothing in this jar that would affect the density or the buoyancy of how much this diver floats or sinks. It is just tap water. There is nothing else in there that would make him float or sink. Remember, we have added some variables, various amounts of sugar, to these other mixtures, and that's what we're going to use for our experimental data. So thank you to the audience, whoever sent that question in. And I think we're probably about ready now to begin comparing these other mixtures to our control. Now don't forget, take a look and make sure that you don't have too much settling in any of your mixtures, particularly your number 3 and 4 mixtures that have more sugar in them. If you're getting any settling at the bottom of the cups, go ahead and just stir those up. So now we're going to look at how far down does the diver dip into these other mixtures, or is it the opposite? Is he going to float? Is it going to be less of a deep dive because there's a greater amount of density in our other mixtures? So this is a great time in the experiment to make a hypothesis about what you think is going to happen. So for those of you at home, I'd like everyone to think to themselves and make a hypothesis. When we move our diver from our control to our experimental variables, what do you think is going to happen? So you could think it to yourself, say it to your brother or sister or your mom or dad, your aunt, your uncle, your cat, your dog, whoever's with you at home right now. Go ahead and tell them your hypothesis for what you think is going to happen when we move the diver out of our control variable into our experimental variables. Are we good? Did everyone tell their dog? Okay. So here we go. We're going to move our diver from our control into jar number 1. Now remember, jar number 1 has 15 grams of sugar dissolved into it. So get down nice and low at eye level and go ahead and try to float them straight up. See what happens. Is it the same level as your control, or can you see more lines above the rim of the glass? If I get right down to eye level, I'm floating at about level 2 or 3. So yours at home should be doing something pretty similar to that. You should be floating at about the 2nd or 3rd line on your straw. And that makes sense, right? Because there's more sugar in our variable number 1 than there was in our control, which had no sugar in it. So there is some stuff, even though we can't really see it, it's dissolved. The sugar particles are really, really small. We can't see them with our naked eye, but they're in here and they are creating density, which is causing our diver to float. So revisit your hypothesis. Were you right? Were you wrong? Were you unsure? We'll make a new hypothesis. We're going to move them into variable number 2. What do you think is going to happen? All right, I am floating at line number 4 or 5. Yep, right about 4, which makes sense because variable number 2 has 25 grams of sugar in it. That's even more sugar. That's a greater density than our control or than variable number 1. So it makes sense that variable number 2 is floating even higher. So what do you think is going to happen in number 3? I hope you guys are seeing the pattern here. Oh, mine is really floating now. Let's see, here we are at 1, 2, 3. It's hard to hold them still. 1, 2, 3, 4, 5, 6, 7. Between number 7 and 8, he's floating in this jar. So again, there's even more sugar in variable number 3. We've got 35 grams in here, so it makes sense that he's floating even higher. And I don't know about you at home, but I can actually see a color difference in jars number 3 and 4 than I can in my other variables, and that's because of all that dissolved sugar, right? We poured a couple spoons worth of sugar into these ones. So now let's check our fourth and final variable and see how we're floating. I am at 1, 2, 3, 4, 5, yeah, right about number 7 and 8 again. So the high density of this mixture is putting me at about line number 7. So that makes a lot of sense, right? We have these mixtures with little to no density at all because we range from no mixture to a little bit to a lot. So it makes sense that the mixture that has the most dissolved particles in it, the sugar particles, is going to create the most floating. And it's the same way that when you go into like a freshwater pool or lake, you don't float as much as you do when you go into the ocean, which is filled with dissolved salts. And do we have a question from the audience? Thank you, Elena. Great question. What is a hypothesis? A hypothesis it's a guess. It is an educated guess about what you think is going to happen in an experiment, right? So in this instance, we made a hypothesis based on what we already knew, right? We knew that we float more in the ocean than we float in a pool. So we made a hypothesis that said, I think that the diver will float higher in the greater density mixtures than in the lower density mixtures, or whatever your hypothesis was. So now we are going to do the fun part. Miss Elena, if I could get your help, please. Dump those for me. Thank you. So now, let's compare our results to some stuff that we actually drink, right? We don't just drink glasses of water with 45 grams of sugar dissolved in them. No, we drink juice, and we drink lemonade, and we drink fruit punch. But how much sugar is really in those? You're about to find out. So when Miss Elena gets back here with my empty glasses, we will be using a couple of my favorite beverages. This is a glass of a bottle of apple juice, and there are 7 servings in this container. So that means that the recommended, oh, thank you, Miss Elena. Fresh and washed. Thank you so much. So that means its recommended serving size is 1/7 of this container of apple juice. And in that serving size is 25 grams of sugar. So whatever you're using at home, go ahead now and pour the same amount. I'm using 200 milliliters, however much you poured into your other glasses. Pour in the same amount. Remember, get low so you can see it. Okay, so that apple juice, remember, has 25 grams of sugar in it, which is actually the same amount of sugar as we dissolved in variable number 2. And this is half and half iced tea lemonade. This container has 2 serving sizes in it, which makes sense, it's smaller. But a serving size of this has 21 grams of sugar in it. So actually slightly less sugar in the iced tea lemonade half and half than we have in our apple juice. So go ahead and pour in whatever you're using, lemonades or iced teas or juice or fruit punch. Just remember not to use anything carbonated or bubbly, because the bubbles are just going to automatically make the diver float up to the top regardless of how much sugar is in there. So you're going to want to use something that is uncarbonated, such as again, lemonade, fruit punch, sweetened iced teas, juices, stuff like that. So we can now make a very educated hypothesis because we know the sugar content of these drinks, and we know that it's about the same as the amount of sugar that we put into variable number 2. So think to yourself, what's your hypothesis here? What's going to happen when we put the diver into these drinks? So I'm seeing him float at about line number 3, which makes a lot of sense because that is right about the same depth that he dove to in variable number 2. Now you might get very different results depending on what it is that you're using at home for your experiment. If you're using fruit punch or lemonade, that might have a very different sugar content than this apple juice that I'm using. And now if we move him into the iced tea half and half, which was slightly less sugar than the apple juice, he's floating around line number 2 or 3, which again makes a lot of sense based on the data that we've already collected. We knew that that's about where he was going to dive to. So whatever you're using at home, you should be able to compare the sugar content on the label of your drink to one of these variables. And now, based on that information, think back to how many tablespoons of sugar we poured into each of these cups. So every time you have a glass of whatever that drink is, you're answering the question, how much sugar is really in my drink? It's a lot. And while it does make these drinks very tasty, very delicious, we don't want to harm our bodies by consuming too much of it, right? Everything in moderation, and there's plenty of healthy alternatives that don't contain nearly as much sugar. Unsweetened iced teas, seltzers, and good old-fashioned water does not contain the high amount of sugar content that we are seeing in things like apple juice and iced tea, fruit punch, and all the other stuff that you guys are experimenting on at home. So I want to thank you all so much for joining us today. I hope that you can continue doing these experiments at home, and feel free to check out Henkel's Researchers World website to learn more about these programs, and we hope to see you again in the future. Have a good night.